Hello, everyone. Welcome. Good morning, good afternoon, good evening, wherever you may be. My name is Daniel Moyer. I'm one of the sales support trainers here at Briggs Stratton Energy Solutions, Simplify Power. We are here today to talk about energy safety, energy storage safety codes and standards. So we're just going to give it 1 second as people kind of drop in here. Couple housekeeping items. If you're going to have any questions, there's a Q&A chat feature. Either it's sometimes at the bottom or the top of your screen, and you'll be able to put in a Q&A there, and we'll either answer the questions during the talk, or we'll have some time to carve out at the end to answer some of those questions. So with that, let's go ahead and get started. So this is kind of the agenda for today. We're going to be talking about why codes and building standards matter, some of the risks associated with energy storage systems, the origin and evolution of these codes and standards. This is really kind of a new industry if you think about it. The first Tesla Powerwall didn't come onto the market until 2015. So really, we're seeing this whole industry in its infancy, and a lot of the code makers, a lot of the stakeholders like building code officials, firefighters are really trying to keep up with these upcoming technologies. So we're also going to talk a little bit about how the NFPA 855, specifically the Chapter 15, which is related to residential, is going to inform codes, either your state or your local codes. So we'll take a look a little bit at that. Finally, we'll round out looking at some of the products that Briggs & Stratton Energy Solutions offers. Q&A at the end. I do want to just give a shout out to some of the references or the material that I used to create this training deck. One of them is from California Solar and Storage Association. It's a local lobby group here in California. If you're part of this here in California market, I would encourage you please to join and become a member. Sequoia Cross, who's my boss, the vice president of Briggs & Stratton Energy Solutions Energy Storage Division, is on the board. Mayfield Renewables, Ryan Mayfield does a lot of great trainings and a lot of great resources I use to leverage in this deck. As well as Solarc, John Cromer, who's the lead of training from Solarc, has the Solarc University. So I attended some of his trainings, all available online, to take a look at some of what he's been able to accomplish, and please reference that. So we'll see that's kind of referenced throughout this. So looks like we're ready to get started. One other reference and source I used for this talk, of course, is the NFPA. So if you haven't seen this, is the NFPA link, and John Cromer promoted this as well. For an annual fee, which isn't very much, you get access to all of the NFPA documents, not just the NFPA 855, which we're going to dive into a little bit. So if anybody in this call has subscribed to this, let us put it in the comments, put it in the Q&A, and let us know if you find it useful. So not only do you get access to all of the documents, but there's also informative notes that go along with all the different codes. Great resource, and again, it's kind of a nominal fee. Another thing coming up, and if anybody's going to be down in Anaheim coming up next, I believe it's in 2 weeks, RE Plus, one of the biggest, largest trade shows for the industry. We're going to be there, Briggs & Stratton Energy Solutions at booth 52025. That's kind of a mouthful. Solarc will be there as well as a lot of other great companies that you can leverage in your business. Thinking of all the different design proposed tools like Open Solar, Aurora, Energy Sage, as well as racking and solar panel manufacturers as well. So with me today also is Rodolfo. Rodolfo, are you here today? I believe he's joining us. So Rodolfo, one of the sales support, he'll be there at RE Plus, and he'll be able to also support any questions that come in as well as we go along. One thing, I've already noticed probably that I've already mentioned Solarc. We really have a great partnership with Solarc. Solarc is an American company, just like Briggs & Stratton. They're one of the first people to come to market with the hybrid inverter, which is when we took all the parts and pieces that used to be separate, like charge controllers and automatic generator starts, put them all into one device, the hybrid inverter. And they've really come to market with a great product, not only to pair well with our batteries, but also to um, pair well with our generators, which we'll talk here in a little bit about. Going a little bit back to Briggs and Stratton, Briggs and Stratton is over a century old, and we have a well-known name brand that a lot of people recognize in the United States and around the world, frankly, mainly for the lawnmowers that you would see in your yard. But we also have a lot of other products, including generators, including energy storage. We're really a company that's going to be around to honor our warranties, and we're also going to be a company that has that great in-house tech support, IT support. We all know how important software is becoming important to this industry. So think about the companies you work with, the brand that stands behind it. About 3 years ago, Briggs and Stratton acquired Simplify Power, which was based out of Oxnard. We're still down there assembling and testing batteries. So really, truly an in-country company that has been leading the industry in safe, reliable energy storage systems, specifically lithium iron phosphate. So as we get into this, I just want to take a step back and understand, the goal of these fire building codes and standards really is to reduce the likelihood of a fire, a catastrophic fire stemming from energy storage products. And really what they're focused on is reducing personal injury, hurting people. Of course, minimizing property damage is part of that as well. But if you look carefully at a lot of these codes and dive into them, it's talking about egress and giving warning to the homeowners. So that's really where we're focused at. And as I mentioned just a few minutes ago, these technologies are evolving so quickly that the codes and standards are typically lagging a little bit behind. If you think about way back in the day when electric lights and electric circuits were coming into the house, again, that code and standards kind of lagged behind and they're playing catch up all the time. But really what we want to see in these codes and standards is that they're implemented in a non-discriminatory way that's based on science and not perceptions. So these codes and standards can have a huge impact on the products that us manufacturers are bringing to market. For example, we all are making batteries that have a 20 kilowatt hour rating. And there are sections in the NFPA 855 that get disseminated into codes that do allow larger than 20 kilowatt hours per individual unit. But when we're looking at these and we're trying to come to market with devices and products, we look at what these codes and standards are saying, and we design and build and sell products accordingly. So it can really affect not only the manufacturers, but the way installers go about doing this. And that's really where I wanted to kind of mention here at the beginning is it's important that you have an understanding of what your local code enforcement, your authority having jurisdiction is going to require before you bid or propose a job. That way you're not surprised when you might fail a code inspection or a permit sign off because you didn't adhere to some of the building and fire codes that we're about to go through really quickly. And I also believe that it takes the collaboration of all of the stakeholders in this industry, from manufacturers, installers, fire marshals, code makers, to create and develop these codes and standards in an appropriate manner. So what can happen? Why can batteries fail? Sometimes it's from us on the manufacturing side, defects, design, and even the installation errors as well. Mechanical abuse, right? I'm thinking of a car crashing into a energy storage system that happens to be in the vehicular path of a vehicle, short circuiting the cell and causing a thermal runaway event. Thermal abuse, right? When we're exposing it to external heat sources, perhaps the house is on fire, unrelated to the energy storage system. I could also see this happening if you're not programming the energy storage system, the hybrid inverter, to treat the battery appropriately. Perhaps you're overcharging it discharging it too quickly, you have your bulk float absorb voltages not correct, that can cause a battery to fail. And then additionally, other outside environmental impacts, right? Floods, extreme heat, maybe a rodent is chewing through something. So again, or maybe somebody is hammering a nail through the wall and hits something. So again, these are reasons, and these failures can lead to fires. And what we see sometimes is thermal runaway, right? That's when you have a battery cell go into a thermal runaway event where it can actually generate more enough heat internally that it causes other cells adjacent to it to then go into a thermal runaway event to vent and then continue to vent as well. Some of these these vents that are put into these energy storage system, the cells designed to release that pressure, can vent flammable gas. And we're starting to see NFPA, or I'm sorry, UL 9540B, the large scale fire testing. There was a great talk yesterday, if anybody had a chance to attend that, where they're starting to not supplant 9540A, but go above and beyond with these large scale fire tests where they purposefully ignite some of this gas that is being vented to look at what happens. So stranded energy as well. When these systems go into an energy to a thermal runaway event, sometimes there's still retained energy inside the cells, and it can be difficult to safely discharge that, especially if the battery has been damaged, like you see in that picture on the right. Another thing to keep in mind is, as manufacturers, we're putting these energy storage systems inside of battery cabinets, inside of battery shells, and then maybe even inside cylindrical cells. So a lot of times these batteries can be very deep seated, and it's hard to cool the cells off when they're enclosed in many layers of metal or aluminum. One thing I want to make sure we cover before we get into the meat of this is that the difference between a standard and a code. So the NFPA 855 is a standard, and a standard a lot of times will inform the code, how to spell out the code. So a lot of times it could be copied just verbatim. A lot of times it will be used with the slightly altered language, and then that is what is the legal document, right? So a standard informs what code has to, what a user must what must be done. So it's important to understand that a code has to be legally adopted by the jurisdiction, and then that's the enforcement. So when we look into this, as we come up on some of these slides, we're not necessarily going to dive into the NFPA 855. We're going to look at the code. Specifically today, we're going to look at the California Residential Code and how that informs this state's code. So as I imagine a lot of you on this call are from around the country and maybe not in California, but keep in mind that the NFPA 855, in a lot of ways, directly informs your local state code or even your local jurisdiction code. So although the language may not be exact in the California code, if you look through it carefully, a lot of the things that they're calling out in NFPA 855 standard informs the code, which then you are legally abided to follow by. So most states have adopted the National Electrical Code for its electrical codes, whereas a lot of the states have adopted I codes from the International Code Council for their building codes, whether it's their residential code, their fire code. So when we're talking to our local authorities, for example, the fire inspector, a lot of times will reference the fire code. A lot of times the residential inspector or the guy at the counter that you're meeting at your building department is going to be referencing the International Residential Code, or if your state has adopted a state building code, it's usually based very similar on that International Code Council as well. So let's keep going. I see a couple questions coming in. Keep them coming, and we'll carve out here a second in a minute. So as I was mentioning, right, NFPA 855, if you were to read that and follow that to a T, you most likely be able to pass an inspection at the state or the local level. But as I'm going to point out here in a minute, some states do alter that NFPA 855 document. For example, here in California, we've recently allowed more cumulative energy storage capacity to be installed on a residential system than is called out in NFPA 855. So there may be things in your local state or even local jurisdiction code that allow you to do more than what NFPA 855. And I would also argue that you could also see things that are more strict. So again, understanding 855 is very important, but I would say looking directly at your international residential code, if that's what your state has adopted, or if they've based your state building codes on that as well. So again, they often have adjustments that are unique to that. And a lot of the states some states actually do adopt the NFPA 855 and NFPA 1 in their state codes, but they're very similar, like I had mentioned as well. So NFPA 855, and doing my research, has been around for a long time. I think really they got their start when fire sprinklers started to make their development into the buildings. They recently, though, and again, I think this is just testament to how recent a lot of these codes and standards related to energy storage are coming about, is that NFPA 855 didn't come out until 2019, relatively new. The International Fire Code, International Residential Code, and NFPA 1 base a lot of their energy storage fire codes on this document, the NFPA 855. What I do want to do is, we only have an hour and we're already about 17 minutes into it. We're going to focus a lot on Chapter 15, which is related to residential installations as well. And if you look carefully in NFPA 855, it talks about how Chapter 15 is going to be the requirement for residential as well. So we'll jump into it really quickly. Again, our California's codes are based on the International Building Code, the International Code Council, and the California Residential Code is based on the International Residential Code. Again, I would also argue, a lot of states around the country haven't necessarily adopted these codes at the same code cycle, and maybe haven't even adopted them at all. So always have that good relationship with your code inspector. Understand what's required before you bid or propose a job, so you're not going to be surprised when you may have to add parking bollards or drywall to a space that you've installed an energy storage system and you didn't have that built into your bid. Looking quickly into the California Residential Code, it's in Chapter 3 for us, Section R328. That was adopted January 1st of 2023, but effective just a few months ago. Again, I just mentioned this, that California now allows a significant increase in the aggregate amount of energy storage system we can put on residents. So again, also keep in mind that in California, like most states, you still have to follow the National Electrical Code when you're doing these installations. So let's get into it. Right off the bat, essentially this R328.1, and I'm going to do my best, everyone, not to read all this verbatim, but this is simply saying that you have to comply with all the provisions. And if you do this, you have to also have the NFPA 850, UL 9540. Now, there is a little confusion around some of this. Right now, there is no battery currently on the market that can pass the cell level test at that 9540A. So a lot of us jump up to the module level and the unit level. But I would say this, that if somebody does come to market with a battery cell that does not go into a thermal runaway during the UL 9540A test, they could potentially put it in somebody's habitable space. And so that is something very interesting. I think that will be there at the market soon. But right now, a lot of the industry is leveraging the lithium iron phosphate and even nickel manganese. Please correct me in the chat for that. Cobalt. Again, also keep in mind that if the energy storage system is less than 1 kWh, it does not need to abide by these following sections that we're going to take a look at. Again, having UL 9540 is a requirement and must be listed and labeled. Notably, if anybody has done this, repurposed EV batteries can be used. You just got to keep them away from a living structure as well, and property lines and public ways. So please don't use your instruction manuals as knee pads. I will say this, that a lot of companies, including us, are putting QR codes on a lot of the products that allow you to access the information with your phone. But you have to follow the installation instructions that we're providing from as a manufacturer so that you're following what we're calling out. And a lot of times when every time I believe when we're doing these UL 9540 listings, we have to send in our manufacturer's instructions as part of that. So always keep these out, make sure you're following these. And we're going to talk about a little bit later, you have to also provide these with the installation site. This is a big one too. Individual units must be separated by 3 feet, except when approved by a large-scale fire testing. So this can be a hindrance. And again, a lot of times some jurisdictions, especially out in the West, even if you do have a UL 9540A showing that you can have closer spacing than 3 feet, they reject that and still call out for that 3-foot spacing. Keep in mind that spacing not only has to be the left, the right, the top, the bottom, but also if you were to say have a battery on 2 walls on either side of the wall as well. And we're going to call this out always in the manufacturing instructions, what that spacing is required to be. This is a great illustration from Mayfield Renewables. And if you haven't looked into Ryan Mayfield, I suggest you do. He has a lot of great trainings that talk about NFPA 855, the UL 9540, UL 9540A. I believe he also has a symposium or a training coming up. Take a look at that, Ryan Mayfield. But what he described here is kind of a great illustration showing the 3-foot minimum spacing, showing the 20 kilowatt hour maximum per unit, again, which can be exceeded if you were to follow some of the other chapters of the NFPA 855. You can exceed that 20 kilowatt hour threshold. But for residential, a lot of manufacturers are keeping in that 20 kilowatt hour segment to make sure, just keep it easy, make sure you can pass these inspections easily. Keep 3 feet away from doors and windows. Notably, these are windows and doors into habitable areas. If the window happens to go into a garage, you can have it closer than 3 feet according to the code, and we'll come up on exactly where that's spelled out here in a minute. Also in garages, right, they're talking about the maximum amount of kilowatt hours you can have in any one of these given locations, and then there's an aggregate amount that allows you to have some in the garage, some on the exterior, some in the basement. So we'll take a look at some of those charts here coming up in a second as well. I think this has been a big one. Now, I've attended a couple talks from California Solar and Storage Association with Jeff Spees mentioned. There's a lot of confusion around where you can put these and having drywall requirements. So we're going to look at drywall here in a minute, but what it's talking about in this section of the California Residential Code, which again, if you go back and look at NFPA 855, it's maybe in a little bit of different order, but it's spelled out almost exactly the same. You can put one of these home batteries in a detached garage, a detached accessory structure. You don't got to do a lot if you do that. But if you are going to put it into an attached garage, make sure that that garage is separated from the living area with drywall. And a lot of times the house, if you have a garage and you go in there and you see bare studs on the side walls and on the roof, you're gonna see drywall between the garage and the living space. You're good to go. If you happen to have a living area above the garage, you're gonna want to have drywall up top. But it's not necessarily true that you're gonna have to drywall the entire garage because you put an energy storage system, right? The perpendicular walls to the living space do not need to have drywall. If you're going to put these into a utility closet, a basement, a storage space, that is drywalled, you're good to go. But if you go into a basement, and that doesn't, we don't have basements mainly out here in California. I'm thinking of you Northeast and you other parts of the country that have basements, and that basement is not finished. You are going to have to add drywall, specifically Type X, which Type X is just the standard drywall, but use that 5/8 inch drywall. So if you go bid a job and you put an energy storage system in the basement, you're going to have to, and it's unfinished, you're going to have to add drywall. And if you didn't include that in your bid, that could be a huge cost that you're now going to have to, all of a sudden, these people are going to have a finished basement as well. So there's a couple workarounds. I've seen sometimes people build like closets inside the garage. And also keep in mind that when we say enclosed spaces, like for example, I'm thinking of like a utility closet. It has to have a door that doesn't enter. It has to have a door that opens to the outside as well. I've had some jurisdictions that allow us to do it in a room where there was a door to the outside and a door to the inside, but they let us go because we had a door to the outside. And again, I think that goes back to understanding what the local code enforcement agency, your AHJ, is looking for in these systems, and make sure you're not just looking at this stuff verbatim. This is going back to that 20 kilowatt hour per unit level. And you can exceed that, but then you have to start to follow some of that commercial code, which starts to get a little more in depth and a little more intensive in what they're asking for. And stay tuned for an upcoming webinar that will offer where we can jump into some of those more nuanced details that come along with following some of the sections outside of Chapter 15 of the NFPA 855. But notably, and we're going to look at here in a second, that in this table R328.5 is coming up on the next slide, that in California, we've recently upped the maximum aggregate amount on the property to 600 kilowatt hours, which is a huge battery bank. And so we'll take a look at what that means. But there is still a cumulative requirements and capacities for certain spaces. For example, the basement is 40 kilowatt hours, the garage is 80 kilowatt hours. And notably, in our code, the California Residential Code, it's talking about now distinguishing energy storage systems on exterior walls, whether they're flammable or non-flammable. And Jeff Spies in that California Solar and Storage Association talked, they brought up, well, what is considered non-flammable material? Is it brick? Is it stucco? Is it aluminum siding, vinyl siding, right? I wouldn't think vinyl siding, but again, that definition of what's a non-flammable surface is going to be defined by your local AHJ. So this is that new table that was just allowed here in California. So this isn't representative of what the NFPA 55 residential section is. And if you look carefully, they're kind of upping the limits to what is allowed in the commercial side while adhering to some of the residential specs. So as I mentioned, you got a basement, a storage closet or something like that, 40 kilowatt hours. Attached garage, 80. You could put 100 kilowatt hours on the outside of a house. But if you happen to have an exterior of a house, the outside of the house that has that non-flammable surface, you can go up to 200. If it's detached garage or detached structure, you can go to 200. And if it's a detached structure that's more than 10 feet away, you could go up to 600. On the ground outside, you could do 200. And if it's on the ground outside more than 10 feet away, you can go up to 600 kilowatt hours. That's a huge system. Put in the comments or the Q&A, please, if anybody has done that much energy storage on a residential property. That'd be interesting to know. This is talking about how we make sure we have to still adhere to the California Electrical Code, which is based on the NEC code when we're installing these energy storage systems. There's also a little bit of language here talking about how we have, for example, with us, we have what's known as a 9540 DC rating, which means that our battery is inverter agnostic. As I mentioned earlier, we really like pairing with Solarc. We've had a lot of great success, but our battery doesn't have to necessarily be used with the Solarc. It can be used with a lot of other inverters on the market. And that is allowed under 9540 as long as that inverter carries that UL 1741. And specifically in California, we need a 1741 SB. And of course, if these inverters are interacting with the grid here in California, we need that Rule 21, which makes sure that grid tied inverters are helping the grid rather than harming the grid with frequency and voltage regulations. So let's just jump into a couple questions. Um, Ken's asking, does Briggs make a battery storage product suitable for commercial applications? I'm thinking of something that operates either 208 or 480 three-phase inverters. And a size at least of 50 kilowatts or 100 kilowatt hours. So yes, we have these, and I'm gonna show you here in a couple minutes. Our 6.6 batteries, our 6.6, our 5 3.8s are all what are known as low voltage batteries, which means that they're 48 volt nominal. So they pair really well with a lot of the 48 volt hybrid inverters on the market. When you start to get up to 208 three-phase or 480 three-phase, a lot of those inverters, I'm thinking of the SolarX 30K or the SolarX 60K, those need minimum battery voltage inputs of like, I believe 160 volts. So in that example, instead of running our batteries in parallel and keeping that 48 volt architecture, we do have batteries available that go up to high voltages that stack in series. So I'm going to have my contact information going to come up here at the end. And what we'll be able to do is put you in contact with some of the high voltage team that can quote out some of those systems. And again, keep in mind that what we're talking about today isn't necessarily going to apply because you're getting into commercial systems at that point. So I think we talked, Bruce. Welcome, Bruce. Good to see you. We do have the UL 9540 with the SolarX as a DC coupled 9540. A couple other questions coming in. Great, thank you. Do the Boss 12 enclosures still need 36 separation between other Boss 12 enclosures? With those, I believe we have the UL 9540A, allowing them a little bit closer spacing. And Ken, thank you. Yeah, we'll get you in touch with the high voltage team. So I think as we're thinking about some of these residential energy storage systems, a couple of just the big ones that come to mind are, of course, you can provide the instructions. Of course, you can keep it to a certain kilowatt hour. But I think what's going to catch up people is drywall requirements and also smoke alarms and heat detectors and parking bollards. So we just talked about drywall. And this is the next big one that I think catches people because what this is kind of saying here is that if you're going to have an energy storage system, you're going to have to put in, and you put it in like a utility closet or basement or somewhere where a smoke alarm is listed to be installed, you got to put a smoke alarm in. And again, check with your AHJs. Sometimes these smoke alarms now have to be interconnected, which means if one of the smoke alarms goes off, all of them have to go off. But if you look carefully at a smoke alarm, and I did this when I replaced one in my house, it says specifically in the instructions for that smoke alarm that you're not allowed to put it in a garage, right? The temperature, the dust, sometimes the humidity inside a garage isn't going to be kosher with that smoke alarm. So you have to put in what are known as heat detectors. And there is a couple of great articles that the California Solar and Storage Association published on these. Really, these heat detectors have to be installed, and they also have to be interconnected. So there is a couple of products on the market, and again, California Solar and Storage Association. Everybody who takes this course is going to get a link, going to get a slide deck, and there's a link down in the bottom left corner that talks about this. These heat detectors, what they do is either measure a temperature above a certain point, or what they'll do is if the temperature rises at a certain rate, it will sound an alarm. Some of these, I would also mention, it's important to understand, are they heat alarms or are they heat detectors? So a heat detector excuse me, is usually part of a larger alarm system, whereas heat alarm is an alarm itself and then can be interconnected. And that first alert one you see on the left is a great example. The problem is that they have to be hardwired, and you got to use, like, I believe it's 14.3. And what that means is that you got the hot and the neutral, and then that other third wire is going to be the white wire. A red wire is going to be used to then interconnect all these, and that can be an expensive proposition when you have to go around the entire house rewiring all the smoke detectors. So Residio is offering a kind of a wireless option. Again, that comes with a local kind of control unit. But these products, Residio makes not only these, but you can interconnect security cameras as well. So understanding these requirements are absolutely. And whenever we did water heaters or furnaces, we would always have to go around and sign off on all the smoke detectors. But now we're looking at having to add these heat detectors in garages. So there is a lot of text here, and I'm not going to read it. What this is talking about really is parking bollards, or impact protection from somebody in a car that might hit an energy storage system that's in the vehicular path. So what they've kind of changed up a little bit is, especially in the California residential code, again, this may differ in yours, is rather than just saying you got to have vehicular protection, what they've now done is giving you some actual methods, some prescriptive approaches. If you do this, you're good. And we're going to look at that here in the next slide. So again, these drywall, these heat detectors, these parking bollards can all be avoided if we put this stuff in a detached garage or on the outside of the structure, which I see a lot of these systems going on to. So again, a lot of text here. Again, and I think this next slide that I'm gonna show you here illustrates a lot of this stuff. Basically, you gotta be able to protect your energy storage system from somebody driving into it, potentially up to a 2,000-pound impact. And this, I think, illustrates it a lot. So if we were to look at all that text that was on the last slide, right? Option one, that pipe baller, I don't see a lot of people doing this, right? What this is talking about is that you actually have to, like, jackhammer out an existing concrete slab and pour concrete and have this post in there. Don't really see that. Wheel barriers, I think, would be interesting. I don't see a lot of people doing this because a lot of homeowners don't like parking bollards in the middle of their garage. I think option 3 is going to be one of the most popular ones if you do have to put these things in. Essentially, what you do is you can buy these, and then from like Granger or I think Uline even might make these. You drill holes, and then you put in, I believe they're Tapcons, and then you can then bolt these bollards into the floor. And I've never seen this happen, but I've heard talk about this, how some of these concrete slab are either, I'm not sure if it's pre-tensioned or post-tensioned. So you have these rebar inside the slab that's under tension. So there may be a risk that you, like, perhaps drill into one of these. That's always, I've heard that, and maybe put into the comments or the Q&A if you've ever thought about that or experienced that or heard of something happening along that lines. So as we look over here to the right, what we're kind of seeing is, right, so if you have some of these energy storage systems that are installed in the path, you got to put in these parking bollards or these curb stops. Ideally, what you want to do is be living over here where it's not, there's like a return wall or a wing wall that's going to protect that vehicle from running into it. And a lot of times I see that happening because most of our service entrances, our load centers, are usually over here on this side wall anyway. So you can save yourself a lot of headache by installing these things where you don't have to put these things in. Not like our good lead acid battery days where you had to have vent fans. These lithium ion batteries, whether it's LFP or NMC, don't vent. And I just want to quickly show how far we've come with these energy storage systems. One of the ways that this industry is being so successful is we're able to, and one of the reasons I think we're all being so careful is that we're packing a lot of energy into these very dense energy storage systems. So on the left, I think those are a bunch of L16s, and they look like the 6-volt version. And that is, 31.6 kilowatt hours. Really, remember, we would only discharge at 50% depth of discharge. That's about 15.8 kilowatt hours. And just to, we probably could do 80% depth of discharge. But on the right is just one of our stacks, one of our 6.6 kilowatt hour stacks with 3 batteries, comes in just under that 20 kilowatt hours. That has the same usable energy storage capacity. We do allow 100% depth of discharge, but that's how much we're able to pack into one space that doesn't require venting or watering for that electrolyte as well. Electric vehicles, and the way we operate these are becoming more intriguing, and that could be in and of itself a whole hour talk. But what this is kind of saying is that if you do have a Tesla and it has a 200 kilowatt hour battery, that you are allowed to park in somebody's garage, temporarily. Use that, maybe, that you can, you don't have to apply to a lot of what we're talking about here. I always felt like this was something we should have been doing all along, is have, like, what we would do is get one of those little, like, from the office supply store, like one of those little file hangers that you would see in an office, and have in there all of your instructions, all of the different manuals that come with the product, whether it's a water heater, whether it's a furnace, whether it's an energy storage system, and have all that right near the energy storage system. I think everybody should have been doing this all along, is having a label with your contact information on it. So something goes wrong, they need a service, they know how to get a hold of you and contact you. Keep in mind that there is other labeling required. And so if anybody does come down to RE Plus, let us know, and I'll gladly walk over you to the PV labels booth. And the amount of labels that I'm seeing having to be installed on these energy storage systems, on these photovoltaic systems, I don't know if it's getting out of hand, but it's definitely a lot. And you can see an example here, that what we just talked about, in what's called out in NFPA 855 isn't all you have to do. There's other labeling requirements that are called out in the NEC code. And I think about, if a firefighter shows up at the house, are they going to read every single label? Maybe some. And so again, having that relationship with fire marshals, your code inspector, is going to allow you to have the appropriate labels. I would always have extra packets of labels on the van, in the trucks at the time of getting my permit signed off. So if they said we need this or that, I could always run out to the van and sticker it up a little bit more if required. These energy storage systems do not vent toxic or hazardous gas during normal use. And we talked about earlier that in a thermal runaway event, these systems are designed to vent that gas. And that's why we're starting to see some of the talk about the large scale fire test, where not only do we send our batteries out for 9540A, where they force the cells into thermal runaway and look at the propagation, but additionally, they do that, but then also have ignition sources that surround the battery cabinet, so that if any venting gas escapes, that it does become ignited. And they look at, does that affect walls, adjacent batteries as well. But for us, during normal use, that's not a problem. So this, I think, is kind of my takeaway on all of this. This is out of the city of Berkeley, here in California, and when you pull a permit, right, to do one of these energy storage systems, they're going to have one of these checklists. And I've seen examples of these checklists of a lot of AHAs around the country. And what I've kind of circled in red, it's fine print, so you don't got to read it all. But again, it's calling out some of those things that we just talked about, the California Residential Code. Again, it's also going to talk about some of the electrical code as well, and some of the submittal requirements. So one quick thing before we get started, I want to just take a look at some more questions. But this is our new stacking battery, 6.6 kilowatt hours per module. You can stack them up to 20 kilowatt hours. pairs well with the great Solar 15K because with our quick discharge rate, 1C discharge rate, one stack of 20 kilowatt hours is going to be enough batteries so that you don't exceed the C rate of those batteries to supply the power that Solar 15K may be called upon to provide. Um, there was talk, Jonathan's talking about, battery management systems fail. And he seems some of this stuff is over the top. And I would, what I'm afraid of is that when we develop these codes and standards, that we do it in a way that includes all the stakeholders. Because what I'm afraid of is that if we start to add too many codes and requirements and restrictions, we're going to see installers that just stop pulling permits, which is absolutely what you do not want to have happen, and you don't want to see people doing. So I do understand the risks associated with energy storage systems, and that these codes are applicable, but we need to develop them additionally. Yeah, heat alarms. Somebody is mentioning garages in the Southwest might exceed 135 degrees. So I would talk to your AHJs that have their own garages that get. Somebody's mentioning heat alarms in garages may actually sound an alarm even if there's nothing happening because the garage is so hot. It's hard to believe that a garage would be 135 degrees, but I believe it. Jonathan's chiming in again, mentioning labeling does help. Um, so we'll keep going here. So we, Jonathan's asking, our safeties we don't actually, some companies do use internal fire suppression systems. Our batteries do not. The way we've been able to have the cell construction, the battery management system, we've proven that through our UL listings, we do not need to have that. Jumping more into the products, with that 6.6 stacking battery, one thing I think I want to call out first off is that it just looks good. And that's, I think, a testament to the industry that solar panels back in the day, had silver frames and a white back sheet. And then all of a sudden, homeowners are wanting black frames, black iron ridge rails, black back sheets, little, hidden fascias that go on the solar panel rails. So I think the same thing can be said true for these energy storage systems, that looks matter just as much as the chemistry. A lot of that other stuff, homeowners don't necessarily care about. The safety, perhaps they do. But if it looks good and it's nice, so having a good looking battery, you can see that here. We do have status LED lights. Of course, all of these energy storage systems comes with apps now. But we still do put that status kind of fuel gauge on the top of the battery. It's not like we go out to the old Power Shack and look at the Trimetrics battery meter and we're tapping the side of it to look at the battery level. They're going to have an app, but they still have a status level. What really, I think, sets us apart is there's a lot of stacking batteries on the market, but they have, if you were to open up the side panels, you still see power conductors and communication cables. With our rapid stack connector, we're stacking both the power and the communications together, and they stack together really nicely with those alignment pins as well. If you come out to RE Plus down in Anaheim, I'll gladly show you. I think we're even going to have kind of a demo where you can stack and unstack these things. Outdoor rated, absolutely. It's wall mountable, which I think makes it look really slick. And of course, we can do it indoors. I think, because this is a code talk, I should mention in unhabitable areas of the house. As soon as we come up with a cell that can pass the cell level test, we'll let you put it in someone's bedroom. One thing I just want to kind of call out on this sheet here is the retained capacity at the end of the life, right? So we have a 10-year warranty, unlimited cycle life, 100% depth of discharge, no throughput clause, and at the end you're going to see a 75% depth of discharge. A lot of cycles in there, and you get more cycles out of a battery. It used to be we would talk always about depth of discharge that affects cycle life. But what we're kind of more shifting that conversation is how fast you're charging and discharge the battery actually can affect cycle life almost as equally, if not more. And that's why we're calling out the different either C over 2, which is zero point 0.5, or C over like I think 1.15 for that 4,500 cycles. Another thing I want to call out is cold weather. Cold weather is just like a 135-degree garage, can affect these batteries. So what we're going to have is cold weather requirements. It's almost always on the charging cycle that you don't want to charge these batteries while cold. This battery can go down to 14 degrees Fahrenheit. A lot of our competitors are up at 32 or 36 degrees Fahrenheit. That is freezing cold for us out here in California. But I know a lot of parts in the Northeast, Milwaukee, Wisconsin, which is where Briggs and Stratton is headquartered, or up in the Northeast, gets that cold. So we do have batteries that have heating options, but a lot of times you're going to want to see these in garages where there's a shared wall with the home, so where some heat is going to leak through there as well. Lithium iron phosphate is the chemistry we've always leveraged, and there's that talking about that cycle life as well. 6,000 cycles, cycling it once a day is like 16 years. This slide, I really just want to talk about how we can scale up to 6 stacks to come in just under 120 kilowatt hours. We have put together packages. These are a great way for people to approach a customer without confusing them a lot, and just have these packages. You can always start high, go less. One thing to keep in mind with these packages is that the batteries that you see, one with the 8K, two with the 12K, three with the 15K, allow that solar converter to discharge the batteries no faster than the C rate that battery allows. And also positioning hours of backup, I think, is a great way to do this. And there's some assumptions we made based on the average kilowatt continuous use rating of a home across the country, and basing also how much of that load you're going to back up based on these packages. And we have other talks where we kind of break these packages a little bit more down, and we can get into some of that fine print as well. The 6.6 stacking battery, it's got a great price point. It's quick to install. It's inverter agnostic, but we do still have some of our other battery available. We still sell I believe one of the few batteries on the market that is a 24-volt lithium iron phosphate battery. It's called the Phi 3.8. It doesn't have closed loop comms built into it. Why? Because if you're on an old Magnasign or an old Outback or some old Trace inverter or something like that, they don't have closed loop communications, right? You got to get into that inverter, make sure you program the bulk, the float, the absorb, make sure that you're not going to exceed the max C rate of the battery. Go ahead and leverage that. That Phi also comes in 48 volts. Amplify does have closed loop communications as well as that 4.9. And then that's what the high voltage modules look on the right-hand side, where we don't run our batteries in parallel. We run them in series. Each one of those modules is 4.3 kilowatt hours. Generators are definitely still part of our repertoire. And I would also say, actually, our generators is one of the larger sectors of our energy storage division. These are air-cooled generators up to 26 kilowatts, and then up to 30 to 200 kilowatt hours, they're liquid-cooled. The larger liquid-cooled commercial generators run at 1,800 RPM, where all of the air-cooled generators run at 3,600 RPM. A lot of interesting ways and abilities to combine energy storage systems and generators together. We have an entire hour-long course where we talk about combining generators and energy storage systems together. I kind of like to think of it as a hybrid car, where perhaps you have energy storage without solar, and the batteries are drained. There's no way to recharge it because grid is down. You can use 2-wire signal to start. You start up that generator, you charge the batteries up with our C/2 charge rate. You can charge up the batteries in 2 hours, run the generator hard, run it at a more fuel efficient point, and then shut the generator off and save fuel, save the noise, save the maintenance that comes along with these generators. Transfer switches still can play a part in combining energy storage systems and generators together. I'm thinking of when you might have a generator that's not feeding into the gen port on a Solarc 15K, but we're actually going to have a transfer switch upstream of the grid port where you could have both grid and generator potentially being fed into that grid port, and then use a transfer switch to transfer back and forth. That just goes to show you how Solarc inverters, and I would say other inverters on the market, are thinking about how generators can be leveraged in. NG Max, really quickly, as we're finishing up the hour, I want to leave a few minutes for questions, is talking about how if you go out and buy a 22K generator and you run it off of propane, you're going to get 22K out of it. But most of the people in the country don't have propane, they're on natural gas. If you run a 22K generator on natural gas, it derates to like 18.5, let's say. Whereas our adjustment of some of the ignition timing inside of our 22K generator, among some of these other models, does allow you to get that full output on NG, natural gas max. A lot of training opportunities available besides this. We have these webinar-based ones. We have live trainings. This is the QR code to join Power Academy. Please, I encourage you to join. And then we're even going to have some what are known as Power Academy Live, where you attend one of these classes, then we're going to jump in. We're going to have some more Q&A and some open forum discussions. That's where we open up everybody to talk, open up the questions, really have more of a interactive discussion rather than more of just a one-way kind of thing. We do always have we have a promotion going. So if you join our IQ installer program, and I will say this, it's not a requirement to be part of this program to install our batteries, but if you do join this program, we're going to offer you some rebates, put your company on the map, and additionally sometimes feature some of your installs in our social media channels as well. We're going to give anybody, not just people of this IQ installer program, $1,000 off your first install. So if you're on the call right now and you do an install and you buy it from one of our approved distributors, which is all the usual suspects like Solagent, GreenTech, Northern Arizona Wind and Sun, $1,000 off that first install. But if you are part of the IQ program, we're going to additionally give you $100 off every battery you install. Thank you, everyone. We're going to look into some of the questions here. My email is energystoragetraining@briggsandstratton.com. It's Basco, briggsandstrattoncompany.com. So again, my name is Daniel Moyer. That's our phone number for some of the application engineers that we're here to help as well. So let's see if we have any more questions. So Jonathan's asking, do we force your products to burn so you can study the effects? And that's exactly what they're doing when we attain a UL 9540A. Ryan Mayfield has some great training that talks about what is that the propagation test, and then additionally, what is a large scale fire test. So absolutely, we have to do that. Jonathan's mentioning that the LED screens don't help. Having the device, is sometimes can be a little harder to install. I would mention this, that having software is becoming very crucial to how these energy storage systems work. Software is becoming very crucial in how the apps work for the software, based on the commissioning of the energy storage system, based on the monitoring of the energy storage system, how the battery management system communicates, how grid solutions, or how an energy storage system might communicate with utilities to charge or discharge themselves based on the commands of the utility. And we have in-house IT tech support team based in Milwaukee that's working every day to make sure the software, the firmware that are on our equipment is of the latest generation. So thank you all for joining, and we'll see you next time. Again, everyone's going to get an email with a copy of these slides, and join us down in RE Plus in Anaheim, and we'll look for you there.